The National Electrical Code, or NEC, does not directly address whether battery storage rooms are classified as hazardous locations. However, the International Fire Code, or IFC, does provide guidance on this matter. Specifically, IFC Section 3004.3.1.1 states that battery storage rooms shall be classified as Class 1, Division 2 locations. This classification signifies that the area is considered to have a potential for containing ignitable concentrations of flammable gases, vapors, or liquids under abnormal operating conditions. It is important to note that neither the IFC nor the NEC includes a provision that allows for an exception to this hazardous location classification based solely on the number of air changes per hour. The idea that a specific number of air changes per hour, such as 6, can automatically negate the hazardous location designation is not supported by these codes. However, local jurisdictions may have their own specific codes or ordinances that could potentially offer such an exception. Therefore, it is crucial to consult with the local authority having jurisdiction or urge to determine if any local requirements apply to battery storage rooms in a specific area. When designing and constructing battery storage rooms, it is generally recommended to adhere to the requirements outlined in both the IFC and the NEC. This proactive approach helps to ensure the safety of occupants and the protection of property. Complying with these codes involves implementing various safety measures, including proper ventilation, explosion-proof electrical equipment, and appropriate signage. Firstly, ventilation is a critical aspect of battery storage room design. Adequate ventilation helps to prevent the accumulation of flammable gases that may be released during battery charging or discharging. Ventilation systems should be designed to provide sufficient air exchange to maintain a safe environment. Secondly, the use of explosion-proof electrical equipment is essential in Class 1, Division 2 locations. Explosion-proof equipment is designed to contain any internal explosions, preventing them from igniting the surrounding atmosphere. This includes lighting fixtures, switches, receptacles, and other electrical devices. Thirdly, appropriate signage is necessary to clearly identify the battery storage room as a hazardous location and to warn personnel of the potential hazards. Signage should include information about the type of hazard present, such as flammable gases, and any necessary safety precautions. In addition to these specific requirements, it is important to consider other safety measures such as fire suppression systems, spill containment, and personal protective equipment, or PPE. Fire suppression systems, such as sprinklers or fire extinguishers, can help to control and extinguish fires in the event of an emergency. Spill containment measures, such as curbs or dikes, can prevent spills of battery acid or other hazardous materials from spreading. PPE, such as gloves, eye protection, and respirators, can protect personnel from exposure to hazardous materials. To summarize, battery storage rooms are typically classified as Class 1, Division 2 locations under the IFC. There is no exception to this classification based on air changes per hour in either the IFC or the NEC. It is important to consult with the local AHA for specific requirements in a given area and to design and construct battery storage rooms in accordance with the IFC and the NEC to ensure safety. Designing a safe and compliant battery storage room involves understanding several key aspects related to the properties of batteries, the hazards they present, and the relevant codes and standards that govern their installation and operation. Batteries, particularly lead-acid batteries commonly used in vehicles, can release hydrogen gas during charging. Hydrogen is highly flammable and can form explosive mixtures with air. This is the primary reason why battery storage rooms are often classified as hazardous locations. The classification as Class 1, Division 2 means that the area is likely to have ignitable concentrations of flammable gases or vapors present under abnormal operating conditions. This could occur due to a battery malfunction, overcharging, or inadequate ventilation. Therefore, the design must prevent ignition sources from coming into contact with these potentially explosive atmospheres. Ventilation is a critical component of a safe battery storage room. While a specific number of air changes per hour isn't a universally accepted exception to the hazardous location classification in the NEC or IFC, adequate ventilation is still essential to dilute and remove any hydrogen gas that may be released. The ventilation system should be designed to provide continuous airflow, preventing the accumulation of flammable gas concentrations. The design of the ventilation system should consider the size of the room, the number and type of batteries stored, and the potential rate of hydrogen gas release. Local codes may specify minimum ventilation rates or require the use of mechanical ventilation systems. Electrical equipment used in a Class 1, Division 2 location must be designed to prevent ignition of flammable gases. This typically means using explosion-proof or intrinsically safe equipment. Explosion-proof equipment is constructed to contain any internal explosions, preventing them from igniting the surrounding atmosphere. Intrinsically safe equipment is designed to operate at low energy levels, preventing the creation of sparks or hot surfaces that could cause ignition. All electrical wiring, conduits, and fittings must also be rated for use in hazardous locations. Proper grounding and bonding are essential to prevent static electricity buildup, which could also be a source of ignition. Fire suppression systems are an important safety feature in battery storage rooms. These systems can help to control and extinguish fires in the event of a battery malfunction or other emergency. Automatic sprinkler systems are a common choice, but other options include clean agent fire suppression systems, which use non-conductive agents that won't damage electrical equipment. Fire extinguishers specifically rated for electrical fires should also be readily available. Spill containment measures are necessary to prevent the spread of battery acid or other hazardous materials in the event of a spill or leak. This can include constructing curbs or dikes around battery storage areas to contain spills. Acid-resistant flooring and coatings can also help to protect the building structure from corrosion. Neutralizing agents, such as baking soda, should be readily available to neutralize any acid spills. Personal protective equipment, or PPE, is essential for personnel working in battery storage rooms. This includes gloves, eye protection, and respirators. Gloves should be acid-resistant to protect against contact with battery acid. Eye protection, such as safety glasses or goggles, should be worn to prevent acid splashes from entering the eyes. Respirators may be necessary if there is a risk of exposure to high concentrations of hydrogen gas or other hazardous fumes. Proper training is essential for all personnel working in battery storage rooms. Training should cover the hazards associated with batteries, proper handling procedures, the use of PPE, and emergency response procedures. Personnel should be trained to recognize the signs of a battery malfunction, such as excessive heat, bulging cases, or unusual odors. They should also be trained to respond to spills and fires safely. Signage is an important safety measure in battery storage rooms. Clear and conspicuous signs should be posted to warn personnel of the hazards present and to provide instructions on proper safety procedures. Signs should indicate that the area is a hazardous location and that smoking or open flames are prohibited. Emergency contact information should also be prominently displayed. Regular inspections and maintenance are essential to ensure the continued safety of battery storage rooms. Inspections should be conducted to identify any potential hazards, such as damaged batteries, inadequate ventilation, or malfunctioning equipment. Maintenance should include regular cleaning, testing of fire suppression systems, and replacement of worn or damaged equipment. Keeping accurate records of inspections and maintenance is important for demonstrating compliance with safety regulations. In addition to the NEC and IFC, other codes and standards may apply to battery storage rooms depending on the specific application and location. These may include the National Fire Protection Association, or NFPA, standards, Underwriters Laboratories, or all standards, and local building codes. It is important to consult with qualified engineers and safety professionals to ensure that the design and operation of battery storage rooms comply with all applicable codes and standards. The specific requirements for battery storage rooms can vary depending on the type of batteries being stored. For example, lithium-ion batteries have different hazards than lead-acid batteries and may require different safety measures. Lithium-ion batteries can experience thermal runaway, a condition in which the battery overheats and can potentially explode or catch fire. Therefore, battery storage rooms for lithium-ion batteries may require more stringent fire suppression systems and ventilation requirements. The design of a battery storage room should also consider the potential for future expansion or changes in battery technology. The room should be designed to accommodate the maximum number of batteries that are likely to be stored in the future. It should also be flexible enough to adapt to changes in battery technology, such as the introduction of new battery types or the development of more efficient battery charging systems. The location of the battery storage room should also be carefully considered. The room should be located in an area that is easily accessible for maintenance and emergency response. It should also be located away from areas that are sensitive to noise or vibration, as batteries can generate noise and vibration during charging and discharging. In summary, designing a safe and compliant battery storage room requires a thorough understanding of the hazards associated with batteries, the relevant codes and standards, and the specific requirements of the application. By implementing proper ventilation, using explosion-proof electrical equipment, providing fire suppression systems, implementing spill containment measures, and providing appropriate PPE and training, it is possible to create a safe and reliable environment for storing batteries. Remember to always consult with qualified professionals in the local authority having jurisdiction to ensure compliance with all applicable regulations. The information provided is intended for general guidance only and should not be considered a substitute for professional engineering advice. Always consult with qualified professionals to ensure that your battery storage room design meets all applicable codes and standards.